Okay, so I'm now doing my third video from chapter 12.5, so I'll label this 12.5C. And this is how do I use z-values to find associated probabilities. Okay, so there's a big difference between a z-value and a probability. So I want to go back and remind you, a z-value tells me how far an individual data point falls from the mean. And the probability is how many people or individuals or items have z-values at or below that level. So I'm going to show you several examples. I'm going to show you the number below a specific value. I'm going to do that first, and then I'm going to talk about the number above a specific value. Sorry, this shouldn't be number, this should be percent. And this should be percent or probability. We'll talk about them both. Above a specific value, and then the percent or probability between two specific values. So I'm going to use these SAT scores of an average of 280 with a standard deviation of 58. I'm not an expert on SAT scores, so please don't send me an email going, that's unrealistic. It doesn't really matter. I could have used anything. I will tell you this, in your practice questions, there's one dealing with what percentage of the fish are above a certain size. That's one that you're going to see on your exam. All right, so anyway, we're moving on. So I'm going to go to the next page and I'm going to do some examples. So on each of these, we'll use the same values. A mean of 280, a standard deviation of 58. So I'm going to write down mu is equal to 280 and sigma is equal to 58. And so here's the question. What percent of students scored below 350 on their SATs? So I'm going to do some steps to help you with this. I think students tend to like steps. So step one, and I always do this step, and students who don't do this step will often miss a problem and they'll come up to me and they'll go, what did I do wrong? And I'll say, where's your step one? Oh, I just don't like to draw the picture. Don't draw the picture, then don't ask me to help you figure out what you're doing wrong. So I'm going to do the picture. It's going to look like this. Every single picture will have a normal curve. You might want to draw a few of those out just so you have them. Okay, and the mean is 280. This person scored 350, so that's pretty far from the mean if you consider the standard deviation is 58. And we're looking for what's the area of what I just shaded on my graph. So what is that area? Well, I can see that that's a big bulk of the curve. It's certainly more than half of it. And so now I've done step one. So I know my answer is going to be definitely probably above 0.7 or 0.8. I just don't know how big it's going to be yet. So step two, calculate the z-score. Calculate z. So z, this is a 350 right here, z is equal to x minus mu over sigma. So in this case, it's 350 minus 280 divided by 58. I'm going to do that on my calculator. You do it on yours and make sure you get the same thing. Remember, you have to do the numerator subtraction before you do the division. So you either need to use a parentheses or you have to put an equal sign in before you divide. So I get 70 divided by 58, and that gives me 1.21. I'm going to round that value to two decimal positions. So 1.21 is the z value. Okay, so what do I do with that? Okay, step three. Look the z value up on a standard normal table and find the area to the left. So a standard normal table will give me the area to the left. If I've sent you one, I'll send you another one with today's notes, but you could just take that and look it up. So I'm gonna have to zoom in on this a little bit so you can see it. I'm gonna look for the value of 1.21. So notice that this here says Z. I don't know if you can see that. I'm gonna zoom down on it here. That says Z there. And this is your first decimal value, and this is your second decimal value. So I'm going to go look for a Z value of 1.21. So I go down here to, make sure you can see it, I go down here to 1.2. Everybody see my fingers on 1.2? This is 1.20 and this is 1.21. And you might go, how do you know that it's 1.20? Because up here, there's a 0, and over here, there's a 0, 1. That's your first decimal position and your second decimal position. So 1.21 has an area of 0.8869. So I'm going to write that down, 0.8869. We're going to put that back up so we can see it. Is the area associated with of a z of 1.21. So I calculate the z and then I go to the table and find the area. So step 4, answering the question, 88.69% of the students scored below 350. Okay, so there we go. All right, so let's do another example. Example 2. What percent of the students scored below, look at my numbers here for a second real quick, 250. So again, mu is 280 for all of these examples, and the standard deviation is 58. So I'm going to do step 1, draw a picture. So here, I'm going to draw my picture, and I put my 280 in, and now I can see that 250 is to the left of that, so I'm going to put my 250 in, and I'm looking for this area. So this is not near as many students. The last answer was 88% of the students. This is not going to be near that many. Okay, so now step 2, calculate the z. Z is equal to x minus mu over sigma. In this case, it's 250 minus 280 divided by 58, which is negative 30 because it's the left, divided by 58. So I'm going to do that calculation. Negative 30 divided by 58, and I get negative 0.52. Now, you might be wondering, why did I round to 2 decimal positions? And the reason is because the table has 2 decimal positions. So I'm going to go to my table, and this one is negative. So I have to go to the negative side of my table. I'm going to zoom in on that a little bit here. And I'm going to go to negative, whoa, let's move that up here. Hope I'm not making it dizzy, 0.52. So there's negative 0.5, negative 0.50, negative 0.51, negative 0.52. And my number is 0.3015. So step 3, we'll say 0.3015, and move that back up so you can see what I'm writing. 0.3015 is the area associated with a z of negative 0.52. So I hope you're starting to realize that the z just brings you to the area. There's no way you can find the area without first finding a z value. And so now step 4, 0.3015 is the probability a student will score under 250, or another way to say that is 30.15% of the students score under 150. Okay? All right, so now I'm going to stop that and we'll go on how do we do more than and how do we do between.